up there. If you guys can see that, all right? I'm making a pink arrow. I was looking for a good color for it, but I think pink is as good as any. All right? So see that X right there? That is how you know that you're dealing in an exponential function. The X alone as the exponent will not indicate if it's exponential growth or decay, but it will tell you that f of x equals something 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 to the x. There you go. That's an exponential function. And you'll remember that from this idea right here. Okay? So this is our basic exponential function situation. All right? Now, if you've got f of x equals a, which is some number, some real number, times b, another real number, to the x, which is your x variable, you're looking at the formula, the standard form for an exponential function. Could be growth, could be decay. Now, a couple of rules exist that I always have to mention. A can't be 0. If a is 0, then you're just dealing with the x-axis. Y equals 0. Boring. That's not an exponential function. And also, b should not be equal to 1. If b were equal to 1, then again, 1 to the anything power is still 1. 1 to the 9,783,643rd power is still 1. Okay? So you don't have an exponential reaction occurring either in growth or decay if b is equal to 1. Also, b should be greater than 0. If b is a negative value, we went over this in class, it oscillates between positive and negative outcomes. Not trying to confuse you guys. I'm trying to keep it simple and sweet here, but if b is a -3, right, and x is 1, then you've got -3 to the 1. That's -3. -3 to the 2. That's +9. -3 to the 3. Well, that's -27. And -3 to the 4. Well, that's +81. Okay? So we're going left and right, back and forth from negative to positive. Things are all just janky and off the charts, and that's not the type of thing that we're trying to model right here, okay? So please remember those restrictions on the values, okay? So I'll just keep this up here in case we need it. Now, looking at this first one, I know that it's exponential because the x is up in the exponent position. Now, how can I determine if it's decay or growth? And if you can remember, go ahead and holler it out. I can almost hear you guys saying the correct answer, which is that you need that value of b to be a certain thing. What's important about b? There's your b, right? F of x equals a b to the x. And your b value, here is 2/3. 2/3, who cares? All right, well, 2/3 is a fraction that's between 0 and 1. It's greater than 0. But it's also less than 1. Okay? So if your b value is greater than 0 but less than 1, then you're not breaking any of our rules. Remember, we said we don't want b to be 1, and we don't want a to be 0. Okay, we're good. We also want b to be greater than 0. So we're cool with all of our restrictions. And then we've got this 2/3 right here. So that 2/3 indicates the only really important aspect of identifying what kind of exponential function you've got. So since that's between 0 and 1, we can say that that's the decay factor. Okay? Decay factor. The decay factor is 2/3, and this is exponential decay. Maybe you still have some questions. Let's look at another one. Okay, how about this one? Let me zoom it a little bit bigger.